Now, in this lecture, we'll answer two questions. In the first question, we'll find out the value of line segment X, that is in rectangle ABCD. In the second question, we'll find out the value of the green shape that is inside a semicircle. So we start with the first question. In the drawing, we have rectangle ABCD. Inside rectangle ABCD, we have a circle. We know that the tangent from point A to this circle equals to 33 units in its length. The tangent from point B to this circle equals to 85 units in its length. The tangent from point C to this circle is unknown, so it is equal to x, and we have to find out the value of x. Likewise, the tangent from point D to this circle is equal to 35 units in its length. Again, our mission is to find out the tangent from point C to this circle, that is to say the value of x. So, first of all, we define the center of this circle as O. We define the point of tendency of the tangent from point A to this circle as E. We define the point of tendency of the tangent from point B to this circle as F. We define the point of tendency of the tangent from point C to this circle as H. And we define the point of tendency of the tangent from point D to this circle as T. We join points O and E together by a straight line. Point O is the center of the circle. Point E is the point on the circle itself. Therefore, OE is the radius of the circle that we will define as R. We have here rule number 1. That the tangent to a circle is perpendicular to the radius drawn to its point of tendency. Here we have tangent AB, that is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, tangent AB will be perpendicular to the radius MO. That is to say, this angle equals to 90 degrees, this angle also equals to 90 degrees, according to rule number 1. We can implement rule number 1 in our drawing, because in our drawing we have the radius OE that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. Likewise, we join points O and F together by a straight line. Again, point O is the center of the circle, point F is the point of the circle itself, therefore OF is the radius of the circle, that is equal to R. And we have the radius OF that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. Likewise, we join points O and H together by a straight line. Again, point O is the center of the circle, point H is the point of the circle itself, therefore OH is the radius of the circle, that is equal to R. We have the radius OH that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. Likewise, we join points O and T together by a straight line. Point O is the center of the circle, point T is the point of the circle itself, therefore OT is the radius of the circle, that is equal to R. And we have the radius OT that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. We join points A and O together by a straight line. and joining points A and O, we created here the right triangle, triangle AOF. We'll implement the Pythagoras theorem on the right green triangle, triangle AOF. According to the Pythagoras theorem, the right green triangle, triangle AOF, triangle AOE, the right green triangle, by PT is the evaluation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AO, therefore the square of the hypotenuse is AO square, and it is equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to OE square plus AE square. After formula, in the right green triangle, triangle AOE, according to the Pythagoras theorem, AO square equals to OE square plus AE square. So AO square equals to OE square. OE is R, therefore OE square is R square plus AE square. A equals to 33 units, therefore AE square is 33 square. So if I know that according to equation number 1, AO square equals to R square plus 33 square. In the next step, we'll join points O and B together by a straight line. And we'll implement the Pythagoras theorem on the right yellow triangle, triangle OBF. The right yellow triangle, triangle OBF by PT the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BO, therefore the square of the hypotenuse is BO square. That is equal to OF square plus FV square. So according to the Pythagoras theorem, the right green triangle, triangle OBF, or BO square equals to OF square plus FV square. So BO square, according to equation number 2, equals to OF square. OF is R, so OF square is R square plus FV square. FV equals to 85, therefore FV square is 85 square. So I found out that according to equation number 2, BO square equals to R square plus 85 square. In the next step, We will join point C and O together by a straight line. And we will implement the Pythagoras theorem on the right orange triangle, triangle OHC. The right orange triangle, triangle OHC. Well, PT CO square equals to LO square plus HC square. Again, the right triangle OHC according to equation number 3, CO square equals to HO square plus HC square. So CO square equals to HO square. HO is R, therefore HO square is R square plus HC square. HC is X, so HC square is X square. So in conclusion, we found out that according to equation number 3, CO square equals to R square plus X square. In the next step, we join points D and O together by a straight line. And we will implement the Pythagoras theorem on the right pink triangle, triangle TOB. According to the Pythagoras theorem, the right pink triangle, triangle TOB, DO square equals to TO square plus TD square. So DO square equals to TO square. TO is R, therefore TO square is R square plus TD square. TD equals to 35 units, therefore TD square is 35 square. So I'm sure you found out that according to equation number 4, DO square equals to R square plus 35 square. In the next step, I will copy the 4 equations that we derived from the Pythagoras theorem, a new page. According to equation number 1, AO square equals to R square plus 33 square. According to equation number 2, BO square equals to R square plus 85 square. Moving to equation number 3. CO square equals to R square plus X square. And according to equation number 4, found out that DO square equals to R square plus 35 square. Okay. In the next step, I'll copy rectangle ABCD if it's circle inside in the new page, and we'll analyze the rectangle if it's circle. So this is rectangle ABCD. If it's circle, that I copy it from the original drawing. In the next step, from the center of the circle that is to start from point O, we go perpendicular on AB. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O to AB is T. But because of the fact that side AB is parallel to side DC, it means that the perpendicular from point O to AB, if we extend it to DC, then that perpendicular will be also perpendicular to DC. Why? Because AB is parallel to DC. So here, this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to the rule that I mentioned, that the perpendicular to AB must be also perpendicular to DC. Why? Because AB is parallel to DC. We define the touching point of the perpendicular from point O and DC as M. In the next step, from point O, we go perpendicular on BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC is point S. Because of the fact that BC is parallel to AD, it means the perpendicular to BC must be also perpendicular to AD. Again, because AD is parallel to BC. So here, this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to the rule that I mentioned. We define the touching point of the perpendicular from point O and AD, it's H. So inside quadrilateral A, we also know that all the angles inside the rectangle are right angles, so this angle equals to 90 degrees. This angle equals to 90 degrees. This angle equals to 90 degrees. And finally, this angle is also equals to 90 degrees. So inside quadrilateral ATHO, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the fourth angle. In total, they must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this angle must be also equal to 90 degrees. Why? Because 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles in any quadrilateral. Okay. In quadrilateral HODM, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. In quadrilateral TVOS, we have 1, 2, 3 right angles. Therefore, fourth angle must be also equal to 90 degrees. And finally, in quadrilateral OSMC, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Okay, so we have inside the rectangle ABCD 4 quadrilaterals. Each quadrilateral has 4 right angles. Therefore, all 4 quadrilaterals inside the rectangle ABCD must be rectangles. Why? Because any quadrilateral that has 4 right angles, you can relate to it as a rectangle. So inside one rectangle ABCD, we have 4 small rectangles. So we define side AH as edge 1, we define side HD as edge 2, we define side AT as B1, and we define side TB as B2. We also know that the opposite sides of a rectangle are equal to each other, so in rectangle AT edge O, side AT must be equal to side edge O. But we know that side AT equals to B1, therefore side edge O must be also equal to B1. Likewise, AH equals to TO, but we know that AH equals to edge 1, therefore PO must be also equal to edge 1. Likewise, in rectangle HDOM, side AO equals to side DM, but we know that side AO equals to B1, therefore side DM must be also equal to B1. Likewise, side AD must be equal to side OM in rectangle AODM, but we know that side HD equals to H2, therefore side OM must be also equal to H2. Likewise, in rectangle TBOS, side TO must be equal to side BS, but we know that side TO equals to edge 1, therefore side BS must be also equal to edge 1. According to the same rule that the opposite sides of rectangle are equal to each other, we get that side TB must be equal to side OS in rectangle TBOS. But we know that side TB equals to B2, therefore side OS must be also equal to B2. And side OM must be equal to side SC, but we know that side OM equals to H2, the cosine ST must be also equal to H2. And finally, side OS must be equal to side MC, but we know that side OS equals to B2, therefore side MC must be also equal to B2. In the next step, we will join points A and go together by a straight line. And we'll implement the Pythagoras theorem on the right triangle, triangle ATO. On the right triangle, triangle ATO, according to the Pythagoras theorem, we get that AO square equals to H1 square plus B1 square. Yeah, the green right triangle AO square equals to H1 square plus B1 square. Repeat again, the green right triangle, triangle ATO, AO square equals to H1 square plus B1 square. We join points O and B together by a straight line. So here, in the yellow right triangle, triangle TOB, according to the Pythagoras theorem, we get that BO square equals to H1 square plus B2 square. Repeat again, in the green, yellow, in the yellow right triangle, triangle BOT, BO square equals to H1 square plus B2 square. We join points O and C together by a straight line. We will implement the Pythagoras theorem on the orange right triangle, triangle OCS. We will get that according to the Pythagoras theorem, in the orange right triangle, triangle OCS, CO square equals to H2 square plus B2 square. And finally, we join points D and O together by a straight line. And we implement the Pythagoras theorem on the pink right triangle, triangle DHO. Actually, this is the pink. We will implement the Pythagoras theorem on the pink right triangle, triangle DHO. According to the Pythagoras theorem, on the pink right triangle, triangle DHO, DO square equals to H2 square plus P1 square. Repeat again, in the right three triangle the edge O, the O square plus H1 square plus B1 square. So in the next step we will create 4 more equations. According to equation number 1, AO square according to equation number 1 equals to AO square according to equation number 2. AO square according to equation number 1 is R square plus 33 square. And it must be equal to AO square according to equation number 2. This equation that is actually H1 square plus B1 square. Likewise, we create equation number 2 that states that BO square according to this equation number 1 must be equal to BO square according to equation number 2. So BO square according to equation number 1 is R square plus 85 square. And it must be equal to BO square according to equation number 2, that is H1 square plus B2 square. The next step we get equation number 3 that states that CO square according to equation number 1 must be equal to CO square according to equation number 2. CO square according to equation number 1 is R square plus X square. And it must be equal to CO square according to this equation and equation number 2, that is H2 square plus P2 square. And finally we create equation number 4 that states that DO square according to this equation number 1 must be equal to DO square according to this equation number 2. So DO square according to equation number 2 is R square plus 35 square. And it must be equal to DO square according to equation number 2, that is H2 square plus B1 square. Okay, so we gathered here 4 equations. In the next step, we subtract equation number 2 from equation number 1. This way we create equation number 5. So, according to equation number 2, we have here R square plus 85 square. Also equation number 1, we have here minus R square plus 33 square. And it is equal to, here we have equation number 2 minus equation number 1. Equation number 2 we have H1 square plus B2 square. That's equation number 1, it is minus H1 square plus B1 square. In the next step, we open the brackets of this equation and equation number 5. And we get here that R square plus 35 square. We have minus before the bracket, so here it will be minus R square minus 33 square. It is equal to H1 square plus V2 square we have minus before the bracket, so it will be minus h1 square minus b1 square. So here we have r square, once r square is 0, so r square will get cancelled, and we left only with 35 square minus 33 square, that is equal to h1 square minus h1 square is 0, so h1 will get cancelled, and we left only with b2 square minus b1 square. So actually, according to equation number 5, we found out that 35 square minus 33 square equals to b2 square minus b1 square. Okay. Here it is actually r square plus 85 square, 85 square. So here it is also not 35 but 85 square. So here it is 85 square minus 33 square equals to b2 square minus b1 square. Okay. So in the next step, we subtract equation number 3 from equation number 4. And you'll get that this way we create equation number 6. Again, we have equation number 4 minus equation number 3. This will be equation number 6. So in equation number 4 we have here r square plus 35 square minus equation number 3 we have here minus r square plus x square, that is equal to h2 square plus b1 square minus h2 square plus b2 square. Here we open the brackets of this equation number 6, and we get that according to equation number 6, r square plus 35 square minus r square minus x square equals to h2 square plus b1 square minus h2 square minus b2 square. So here r square minus r square is 0, so r square will get cancelled. Here we have h2 square minus h2 square is 0, so h2 square will also get cancelled, and we left only with, in this side of the equation, 35 square minus x square equals to b1 square minus b2 square. So here we'll multiply this equation number 6 by minus 1, and we get that according to equation number 6, minus x squared times minus 1 is plus x squared, 35 squared times minus 1 is minus 35 squared, and it is equal to minus b2 squared times minus 1 is plus b2 squared, b1 squared times minus 1 is minus b1 squared. In the next step, we create equation number 7, it says that b2 square minus b1 square according to equation number 5 must be equal to b2 square minus b1 square according to equation number 6. So here b2 square minus b1 square according to equation number 5 is 85 square minus 33 square, and it must be equal to b2 square minus b1 square according to equation number 6, that is actually x square minus 35 square. So in conclusion, actually found out that according to equation number 7, '85 square minus 33 square equals to x square minus 35 square. Here we'll add 35 square to this equation, equation number 7, and we get it according to equation number 7, 85 square plus 35 square minus 33 square equals to x square. So 85 square is 7,225 plus 35 square is 1,225 minus 33 square is 1,089. It is equal to x square. Here 7,225 plus 1,225, it is equal to 8,450 minus 1,089 equals to x squared. So 8,450 minus 1,089 equals to 7,361. That is equal to x squared. Here we take a root, we take a root from this equation, equation number 7, and we get that according to equation number 7, x equals to plus minus to the square root of 7,361. Well, because of the fact that x is a length, s is a length, x is a length, x is a length must be a positive number. Therefore, we take into account only the positive result. That is to say, the value of line segment x will be equal to 85.796 square units. Finish with the first question. In the next step, I will run through the second question, and we'll solve the second question in two different methods. In the drawing, we have a semicircle. You know that AB equals to 6 units. AB is the diameter of the semicircle that is equal to 6 units. Angle BAC equals to 30 degrees. And our mission is to find out the area of the grain shape. So we define the center of this semicircle as O. AO is the radius, OB is also the radius. We know that the radius of any circle is half the diameter. And we know that the diameter is 6 units, therefore the radius must be equal to half of it. That is to say the diameter must be equal to 6 over 2, that is 3 units. So AO, that is the radius, is equal to 3 units. OB, that is also the radius of the semicircle, is equal to 3 units. We join points O and C together by a straight line. Point O is the center of the semicircle, point C is the point of the semicircle itself. Therefore OC is the radius of the semicircle, that is equal to 3 units. In triangle AOC, side AO equals to 3 units, so side OC equals to 3 units. Therefore those two sides are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. So inside triangle AOC, this angle equals to 30 degrees, this angle equals to also to 30 degrees, 30 degrees plus 30 degrees is 60 degrees. Therefore, the missing angle must be equal to 120 degrees. In order to complete the sum of the angles in this triangle to 180 degrees, this angle must be equal to 120 degrees. Okay. What is the area of a sector? So if we have here sector AOB, this is sector AOB. First of all, sign for the area of a sector. Here this is sector AOB. The sign for a sector is the rounded side. The rounded side. So this means that the area of sector AOB will be equal to the area of the circle that contains the sector, that is to say pi r square. Here the legs of the two OA and OB, they are the area of the circle that contains the sector, that is equal to r, and the angle between the legs of sector OA and OB is theta. Then the area of this sector will be equal to the area of the circle that contains the sector, that is to say pi r square, times theta over 360 degrees. Here, this ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the entire circle. And when we will multiply this relative percentage by the area of the entire circle, that is pi r square, we'll get exactly the area of the sector, sector A or B. So the area of sector A or B equals to pi r square times theta over 360 degrees. We'll use this formula in order to find out the area of sector A or B. So I copy sector A or B in the new page and use the new formula in order to find out the area of sector A or B. So we find the area of sector A or C. So this is sector A or C, the decorator of the original drawing. So the area of this sector, sector A or C, according to the new formula, will be equal to pi r square, but r equals to 3, so it is pi times 3 square times theta over 360 degrees. Theta is the angle between the legs of the sector that dissociate is equal to 120 degrees over 360 degrees. So here 3 square is 9, so this expression in total equals to 9 pi. 120 degrees over 360 degrees is 1/3. So in conclusion, found out that the area of sector A or C equals to 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So I found out that the area of sector A or C is equal to 3 pi square units. In the next step, we'll find out the area of triangle A or C and present to you a new formula for the area of any triangle. So if we have triangle A or C, that could be any triangle. This is triangle A or C. Actually here we have triangle ABC, that could be any triangle. The length of side AB is A units, the length of side AC is B units, and the angle between side AB and side AC is theta. Then according to the new formula, the area of this triangle, triangle ABC, will be equal to A times B times sinus theta over 2. Okay, again, the area of this triangle, triangle ABC, that could be any triangle, it is equal to A times B times sinus theta over 2. We'll implement the new formula in order to find out the area of triangle A or C. So I copy triangle A or C this new page and we'll implement the new formula to find out the area of triangle A or C. So actually this is triangle AOC as I call it from the original drawing. According to the new formula, the area of this triangle AOC will be equal to AO times OC times sinus 120 degrees over 2. That is to say, the area of triangle AOC will be equal to AO, that is 3, times OC, that is also 3, times sinus 120 degrees is equal to 3 over 2, all divided by 2. 3 times 3 is 9, so it is here in the numerator we have 9 times 4 to 3 in total, over 2 times 2, that is 4, so in the denominator we have 4. So we found out that the area of triangle AOC is equal to 9 times 4 to 3 over 4 square units. And we've already found out that the area of sector AOC equals to 3 pi square units. But what is the area of the green shape? On drawing, it is very easy to see that the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. Repeat again, the area of sector AOC minus the area of triangle AOC equals simply to the area of the green shape. Repeat again. The area of the green shape equals to the area of triangle AOC minus the area, again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC. We already found out that the area of triangle AOC equals to 9 times square root of 3 over 4. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. In the next step, I present to you second method to find out the area of the green shape. According to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector BOC. repeat again. The area of the green shape according to the second method equals to the area of the semicircle minus the area of triangle AOC minus the area of sector BOC. What is the area of the semicircle? The area of the semicircle equals to the area of the circle over 2. That is to say, it will be equal to pi r square over 2. R equals to 3, therefore it is pi 3 square over 2. 3 square is 9. So in total, this expression equals to 9 pi over 2. So actually found out that the area of the semicircle, equals to 9 pi over 2 square units, and we have already found out in the first method that the area of triangle AOC is equal to 9 times 4 to 3 over 4 square units. The only thing that is left to do in order to find out the area of the green shape is to find out the area of sector BOC. The area of the sector BOC. Okay. We know that AB is a diameter, it is a straight line. So if we focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have in the upper side of AB at point O? We have that this angle is equal to 120 degrees plus the missing angle. In total, they must be equal to 180 degrees. So this angle must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB at point O to 180 degrees, this angle must be equal to 60 degrees. So in the next step, I will copy sector COB in a new page and we'll find out the area of this sector COB. So this is sector COB that I copied from the original drawing. We know that the area of any sector, according to the new formula, is equal to pi r square times theta over 360 degrees. R is the radius of the circle that contains the sector. Theta is the angle between the legs of the sector. So according to the new formula, the area of sector COB will be equal to pi r square. R is 3, so pi r square is pi 3 square. The angle between the legs of sector COB is 60 degrees, so theta equals to 60 degrees, so it is 60 degrees over 360 degrees. So 3 square is 9, so it is 9 pi times 60 degrees over 360 degrees. 60 degrees over 360 degrees is 1 over 6. In total, this expression equals to 9 pi over 6. Here we'll divide both the numerator and the denominator by 3. 9 pi over 3 is 3 pi. 6 over 3 is 2. So in conclusion, we found out that the area of sector COB equals to 3 pi over 2 square units. So what is the area of the green shape? The area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Okay, repeat again. The area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle equals to 9 pi over 2. The area of triangle AOC equals to 9 times square root of 3 over 4. And the area of sector COB equals to 3 pi over 2. 9 pi over 2 minus 3 pi over 2 is 6 pi over 2 minus 9 times square root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi minus 9 times square root of 3 over 4. So I found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. We finish with the second method. The next step, I'll summarize the lecture. We'll start with the first question, of course. So in the drawing, we have rectangle ABCD. Inside rectangle ABCD, we have a circle the tangent from point A to this circle equals to 33 units in its length. The tangent from point B to this circle equals to 85 units in its length. The tangent from point C to this circle is unknown, so it is x. We have to find out the value of x. And finally, the tangent from point D to this circle equals to 35 units in its length. So the mission is to find out the value of x. First of all, we define the center of this circle as O. We have the radius OE that is drawn to the point of tendency, therefore for the rule number 1, this angle equals to 90 degrees. We have the radius OT that is drawn to the point of tendency, therefore for the rule number 1, this angle equals to 90 degrees. We have the radius OF that is drawn to the point of tendency, therefore this angle equals to 90 degrees according to rule number 1. And we have the radius OH that is drawn to the point of tendency, therefore for the rule number 1, this angle equals to 90 degrees. Then we joined points A and O together by a straight line. In this way, we created a green eye triangle, triangle AOF, A from E. According to the Pythagoras theorem, and the right green triangle, triangle AOE, AO square plus OE square equals to AE square. AO square, again, the green line triangle, AO square equals to OE square plus AE square. OE equals to R, AE equals to 33. So therefore AO square equals to OE square, that is R square, plus A square, that is 33 square. So according to question number 1, I found out that AO square equals to R square plus 33 square. Next step, we join points P and F together by a straight line. We implemented the Pythagoras theorem on the right yellow triangle, triangle BOF. According to the Pythagoras theorem, BO square equals to OF square plus BF square. OF is R, BF is 85. Again, BO square equals to OF square plus FB square. OF is R, so OF is R square plus FB square. FB is 85 plus F plus, so FB is 85, so FB square is 85 square. So in conclusion, we found out that according to equation number 2, BO square equals to R square plus 85 square. Okay, so then we join points C and O together by a straight line. Created in this way, the orange right triangle, triangle OCH. In the orange right triangle OCH, OC square equals to OH square plus HC square. OH is R, HC is X. So here CO square equals to HO square plus HC square. HO is R, so HO square is R square. HC is X, so HC square is X square. So in conclusion, we found out that according to equation number 3, CO square equals to R square plus X square. Then we join points D and O together by a straight line. Here, in this way, we created the pink right triangle TOD. The pink right triangle, according to the Pythagoras theorem, OD square equals to TO square plus TD square. Okay, again, OD square equals to TO square plus TD square. TO is R, TD is 35. Therefore, DO square equals to PO squared is R squared plus TD squared, that is 35 squared. According to equation number 4, we found out that DO squared equals to R squared plus 35 squared. Then I copied the 4 equations in a new page, and then actually I copied rectangle ABCD with its circle. This is rectangle ABCD with its circle inside it. Then from point O we draw perpendicular on BC. This angle equals 90 degrees, this angle equals 90 degrees according to our construction. But because of the fact that side BC is parallel to side AD, it means that the perpendicular on to BC must be also perpendicular to AD, again because of the fact that BC is parallel to AD. So this angle will be equal to 90 degrees, and this angle must be also equal to 90 degrees. Likewise, from point O we draw perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. Then the perpendicular to AB must be also perpendicular to DC. Why? Because AB is parallel to DC. So this angle equals to 90 degrees, and this angle equals to 90 degrees. According to the rule that I mentioned, that because of the fact that AB is parallel to DC, then the perpendicular to AB must be also perpendicular to DC. So, in quadrilateral AT edge O, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So this angle must be also equal to 90 degrees. Likewise, in quadrilateral NODM, we have 1, 2, 3 degrees, therefore the fourth angle must be also equal to 90 degrees. Quadrilateral DBOS, we have 1, 2, 3 degrees, therefore the fourth angle must be also equal to 90 degrees. And finally, in quadrilateral OSCM, we have 1, 2, 3 degrees, therefore its fourth angle must be also equal to 90 degrees. So inside rectangle ABCD, we have 4 quadrilaterals with 4 right angles, therefore all 4 quadrilaterals are rectangles. Why? Because any quadrilateral that has 4 right angles, we can relate to it as a rectangle. Okay. Then, in rectangle, we define side A edges H1, side A HD as H2, side AT as V1, and side TB as V2. We know that the opposite sides of a rectangle are equal to each other. So in rectangle AHTO, AT equals to A edge O. But we know that AT equals to B1. We know that AT equals to B1, therefore edge O must be also equal to B1. Likewise, AH equals to TO, but we know that AH equals to H1, therefore TO must be also equal to H1. Likewise, we know that in rectangle edge ODM, edge O must be equal to DM. But we know that edge O equals to B1, therefore DM must be also equal to B1. Likewise, HD must be equal to OM, but we know that HD equals to H2, therefore OM must be also equal to H2. Likewise, in rectangle TOBS, TB equals to B2, therefore OS must be also equal to B2. TO equals to H1, therefore BS must be also equal to H1. And in rectangle OSMC, OM equals to H2, therefore SC must be also equal to H2, and finally OS equals to B2, therefore MC must be also equal to B2. Then we join points A and O together by a straight line. This way we created triangle ATO, the right triangle, according to the Pythagoras theorem. AT square, B1 square plus H1 square equals to AO square. Then in the right triangle, triangle BTO, this will be equation number 2, H1 square plus B2 square equals to BO square. Then in the orange triangle OSC, B2 square plus H2 square equals to OC square. In the big triangle ODH, B1 square plus H2 square equals to DO square. Okay, so in this way we created those four equations. Then we created the first equation that states that AO square according to equation number 1 must be equal to AO square according to equation number 2. Then we created equation number 2 that states that BO square according to equation number 1 must be equal to BO square according to equation number 2. Then we created equation number 3 that states that CO square according to this equation number 1 must be equal to CO square according to this equation number 2. And finally we created equation number 4 that states that DO square according to this equation number 1 must be equal to DO square according to equation number 2. So those are the four equations that we created. Then we subtracted equation number 1 from equation number 2. So here we have equation number 2 is r square plus 85 square minus r square plus 33 square equals to h1 square plus b2 square plus h1 square plus b1 square. Then we open the brackets of equation number 5 and we found out that r square plus 85 square minus r square minus 33 square equals to h1 square plus b2 square minus h1 square minus b1 square. R square minus r square is 0, h1 square minus h1 square is 0, so we have to leave 85 square minus 35 minus 33 square, that is equal to b2 square minus b1 square. Then we subtracted equation number 3 from equation number 4. And we got this expression, we open the brackets here. And finally, according to equation number 6, we found out that 35 square minus x square equals to b1 square minus b2 square. Then we multiply this equation number 6 by minus 1. And we got that x square minus 35 square equals to b2 square minus b1 square. Then we created equation number 7 that states that b1 square minus b2 square according to equation number 5 must be equal to b1 square minus b2 square according to equation number 6. Actually, b2 square minus b1 square according to equation number 5, it is equal to 85 square minus 33 square. It must be equal to b2 square minus b1 square according to equation number 6, that is equal to x square minus 35 square. We added 35 square to this equation and found out that 85 square plus 35 square minus 33 square equals to x square. 85 square is 7,425, 35 square is 1225, minus 33 square. 33 square is 489, that is equal to x square. 7,225 plus 1225 is 8,450 minus 1,089 equals to x square. 8,450 minus 1,089 equals to 7,361. That is equal to x squared. Then we took out of this equation number 7, and found out that x equals to plus minus the square root of 7,361. So here we have two solutions that are possible for x, but because of the fact that x is a left, it must be a positive number, so we take into account only a positive solution. That is to say, we found out that the left of line segment x equals to 85.796 units. We finished with the first question, then I presented to you the second question, and solved the second question in two different methods. In the drawing, we have a semicircle. You know that the diameter of the semicircle AD equals to 6 units, angle BAC equals to 30 degrees, and our mission is to find out the area of the green shape. Okay, so we define the center of the semicircle as O. We know that the diameter of the semicircle is 6, therefore the radius must be equal to half of it, that is to say it must be equal to 3. The joint points O and C together was that time. Point O is the center of the semicircle, point C is the point of the semicircle itself, therefore OC is the radius of the semicircle, that is equal to 3 units. In triangle OSC, OA equals to 3 units, OC equals to 3 units, therefore OA equals to OC, and we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. We know that the sum of the angles in any triangle is 180 degrees. 30 degrees plus 30 degrees is 60 degrees, so the missing angle must be equal to 120 degrees. What is the area of the sector? If we have a sector A or B, that could be any sector. The sector A or B, the angle between the legs of the sector is theta. OA and OB are both the radii of the circle, that is equal to R. So the area of this sector, sector A or B, equals to pi r squared, that is the area of the circle that contains the sector, times theta over 360 degrees. Theta over 360 degrees gives us the relative percentage that this sector occupies out of the entire circle, and we will multiply this relative percentage by the area of the entire circle, that is pi r squared. We get exactly the area of the sector A or B. We implemented the new formula in order to find out the area of sector AOC. This sector AOC. So I copy sector AOC here. AO and OC are both the area of the circle, of the semicircle. The angle between the legs of the semicircle of the sector AOC is 120 degrees, so the area of sector AOC equals to pi r squared. R is free, so pi r squared is pi free square. The angle between the legs theta is 120 degrees, so it is 120 degrees over 360 degrees. So in conclusion, pi free square is 9. So in total this expression equals to 9 pi. 120 degrees over 360 degrees is 1/3. So in conclusion, we found out that the area of sector AOC equals to 9 pi over 3. 9 over 3 is 3. So in total, we found out that the area of sector AOC equals to 3 pi square units. Then I presented to you a new formula for the area of any triangle. This is triangle ABC, that could be any triangle. We know that the length of side AB is a unit, the length of side AC is B units, and the angle between side AB and side AC is theta. Then the area of this triangle ABC equals to A times B times sinus theta over 2. We created the new formula in order to find out the area of this triangle AOC. AO equals to 3, CO equals to 3, the angle between AO and CO is 120 degrees according to the formula. The area of this triangle AOC will be equal to AO times OC times sinus 120 degrees over 2. AO is 3, CO is 3, sinus 120 degrees is equal to 3 over 2, all divided by 2. 3 times 3 is 9, so in total is in the numerator we have 9 times root of 3. In the denominator we have 2 times 2, that is 4. So in total we found out that the conclusion that the area of triangle AOC equals to 9 times root of 3 over 4 square units. We have already found out that the area of sector AOC equals to 3 pi square units. But what is actually the area of the green shape? The area of the green shape will be equal to the area of sector AOC minus the area of triangle AOC. Again, the area of sector AOC minus the area of triangle AOC equals exactly to the area of the green shape. Repeat again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. The area, we already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC. We already found out that the area of triangle AOC equals to 9 times root of 3 over 4 square units. So in conclusion, we found out that the area of the green shape equals to 3 pi minus 9 times root of 3 over 4 square units. So in terms of numbers, it is equal to 5.53 square units. We finished with the first method, then I presented to you how to find out the area of this green shape according to the second method. According to the second method, the area of this green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Again, the area of this green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Repeat again, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector BOC. The area of the semicircle, it is equal to the area of the circle over 2. The area of the circle is pi r squared, and if we divide it by 2, we get the area of the semicircle. R equals to 3, so pi r squared is pi 3 squared over 2. So 3 squared is 9, so in total this expression equals to 9 pi over 2. So we found out that the area of the semicircle equals, in conclusion, to 9 pi over 2 square units. We have already found out in the first method that the area of triangle AOC equals to 9 times root of 3 over 4 square units. The next, the only thing that is left to do in order to find out the area of the green shape is to find out the area of the sector COB. What is the angle between the legs of sector COB? You know that AB is the diameter of the semicircle. AB is the diameter, must be a straight line. If you focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees according to rule number 3. Then the sum of the angles on one side of a straight line is equal to 180 degrees. So 120 degrees plus the missing angle must be equal to 180 degrees. Therefore the missing angle must be equal to 60 degrees. 120 degrees plus 60 degrees is 180 degrees. That is the sum of the angles on one side of a straight line. So this angle must be equal to 60 degrees. In the next step, I copied sector COB in this new page. Here we found out that the angle between the legs of sector COB equals to 60 degrees. OC and OB are both the radii of the semicircle that is equal to 3 units. So according to the new formula, we know that the area of any sector is pi r squared times theta over 2. R is the radius of the circle, theta is the angle between the legs of sector COB. So here R is 3, and theta is 60 degrees. So in conclusion, we found out that the area of sector COB equals to pi r square. R is free, so pi r square is pi free square. The angle between the legs of sector COB is 60 degrees. So it is theta over 360 degrees is 60 degrees over 360 degrees. Pi free square is 9, so in total this expression equals to 9 pi times 60 degrees over 360 degrees. 60 degrees over 360 degrees is 1 over 6. So in conclusion, we found out that the area of sector COB equals to 9 pi over 3 square units. Divided both the numerator and the denominator of this expression by 3. 9 over 3 is 3, so total the numerator we have 3 pi. 6 over 3 is 2, so here the denominator we have 2. So in conclusion, we found out that the area of sector COB equals to 3 pi over 2 square units. Okay, again, what is the area of the green shape? The area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Okay, and we've already found out that the area of the semicircle equals to 9 pi over 2 square units. We've already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. And finally, we've already found out that the area of sector COB equals to 3 pi over 2 square units. 9 pi over 2 minus 3 pi over 2 is 6 pi over 2, minus 9 times square root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. Okay, thank you very much.